Alright, welcome class. This is the 8.1 Ready, Set, Go homework solutions. Here we have the ready part. It says to find the distance between two points. You have this image here. What I did, some of you don't have some of these numbers, and I decided to put those values in. Like this was negative 3.5. How do I get that? Notice every single unit from 0 is 0.5. So do you see how you went to the left? That's 0.5. This would be negative 1, negative 1.5, negative 2. Do you see how every increment is 0.5? So in using that, that's how I got the values of negative 0.5. This is negative 1, negative 1.5, negative 2 for C, negative 2.5, 3, negative 3.5, and that's negative 4. Likewise, to the right, it's also positive. Positive 1.5, 1, 1.5, 2, 2.5, 3, 3.5, 4. I label the values so I could get the numbers much easier. Here the question asks us to find the distance, so I need you to understand the formal definition of distance. When it comes to coordinate geometry, distance is defined between 2 points. The formula, it's final minus initial, that is always distance. Distance is the change of 2 points, that's why the final minus the initial, okay? But also understand we sometimes might have to take an absolute value, so we could always get a positive value for the distance. Alright, next one, number 1. I think the point was A to E. A to E, the line A to E is defined as E minus A because again it starts at A, it goes to E. The formula for distance is final minus initial. So it's E minus A. I need the values of A, which is negative 4, and E is 2. Plug that in, it's 2 minus negative 4. You get AE equals to 6. So the distance from A to E has the value of 6. Same thing here. The next one is CF. CF is defined by the change of F minus C. F is 2.5. C is negative 2. You do that subtraction. 2.5 subtract negative 2. You get CF equals to 4.5. Okay, the process is repeated for 3 and 4. Same thing, always it's final minus initial. The second letter minus the first letter. Okay, there you go, and that is number 4. Number 4, the difference about number 4 is when you do negative 4 subtract negative 2, you got a negative 2 as the answer. Okay? But you can never have a negative distance. It's a physical object. So you have to take the absolute value. The absolute value of negative 2 is 2. So you would say CA is 2. It would make no sense. It wouldn't make sense for CA to be negative 2 because it is a distance. Alright? There you go. And that is 5. Here's 5. And here's 6. Alright? The calculation, again, it's always final minus initial. And I get those values. Be very careful when you're doing the subtracting a negative. Just plug into a calculator so you do not get the negatives confused. But there you go. If you have any questions, let me know. Let me just slow it down for you. That's 1, 2, 3, and 4. 5 and 6. The explanation for all of them are the same. So I'm not going to just repeat the same explanation 6 times. Right? Get the value for E. The first letter, get the value for the second letter. The distance is always the second letter or the second point, the final point minus the first point. Alright, let's do 7. It says describe a way to find the distance between 2 points on a number line without counting the spaces. We did this in the mall activity. I'm just going to repeat myself. You create the distance formula by combining the formula for the x-axis and the y-axis. Okay, the distance in the x-axis is defined as the final value of the x minus the initial value of the x. So it's x2 minus x1. The distance in the y-axis is y2 minus y1. The issue is this: how are we going to deal with negative values? So we have to square both sides. So we have the initial distance in the x-axis plus the distance in the y-axis, but we have to square both terms so we could get positive values. If we square on the right hand side, we also have to square on the left hand side. That's why D is squared, right? Because that is the distance. we want the distance by itself, so the letter D by itself. So the inverse of the power 2 or the squared is the square root. That's how you got this formula. This formula is just the square root of your change of the x-axis squared plus your change in the y-axis squared. Let's do 8. I got 4 and 5 here by just counting the values of A and B. To find C, let AC, so the line AC here is going to be defined by C. It is the hypotenuse. How do I know? I can use Pythagorean theorem because it is a right triangle. How do I know it's a right triangle? AB is a vertical line, BC is a horizontal line. Horizontal and vertical lines always intersect at 90 degrees, making a perpendicular angle. Hence, it can be a right triangle. A is 4, B is 5, C, which is defined as A to C, is what I'm going to label as my C, or my hypotenuse unknown. A squared plus B squared equals C squared. Make the substitution in. 4 squared plus 5 squared equals C squared. 16 plus 25 equals to C squared. 16 plus 25 is 41 equals C squared. I need to get C alone by doing the inverse. The inverse of the squared is the square root. I square root both sides. I get C equals to the square root of 41. So AC here has the value of 41. So the distance of AC is 41. 9. Why is it easier to find the distance between point A and point B and point B and point C than it is to find the distance between AC? So this really makes this question is very stupid because it's easier if it just makes sense to you. Right? You could do it the long way. It doesn't matter if it makes sense to you. It's perfectly fine. But the logic they're trying to get you to understand is this, right? The coordinate grid that we have here is in two axes, the x and the y. Hence, we want to find the distance in only those directions. Any direction that is not in the x or y, for example, AC, which is diagonal, right? It goes from here to here. That's diagonal. Will have to be a combination of both, which is the change of y and the change of x and the change of y. See, this diagonal line, in high school, you're going to learn something about polar coordinates. Things that are diagonally like this work so much better in something called polar coordinates, as well as something in college, we call that vectors, right? So, but for now, the fact that we only work in the x and y, the coordinate plane in the x and y, that is the reason why we have to find those distance of change of y and change of x. Alright, 10. Explain how you find the distance formula for AC. Again, please refer back to 7 as the explanation and 8 as the example to answer 10. Okay, but in short, you would use the Pythagorean theorem. Alright, let's look at the set part. Set part, what does the value y2 minus y1 tell you? Again, that tells you the change in the y direction because this is y, so this would be the change in the y direction. What does x2 minus x1 tell you? That would be your change in the x direction. Alright, so find what AB is. So A was the 2 points, 2 and 2, and B is 6, 4. The first value is x1, this y value here is y1. The B is going to be my second value, so x2 is 6, y2 is 4. The distance formula here, you make the substitution. Look at the algebra, 4 squared, 2 squared, 16 squared. The distance of AB is equal to the square root of 20. Remember, this is AB. If this makes more sense to you, okay? AB, 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 AB. Okay, there you go. Find AB. Alright, for the next one. The next one, same thing, but here you have different points. X2 is 2, x1 is 2, y1 is 1, B, which is our second value, so x2 is 5, y2 is 16. Again, you have to label these so you could plug into the distance formula. Here's the distance formula. Make the substitution. Be very careful. 5 minus 2 is 3, 16 minus 1 is 15. 3 squared is 9, 15 squared is 225. Add it together, you get the square root of 234. Notice this 12 and 13, they're done the same exact way. The only difference is the coordinates change. Therefore, The numbers are going to change. Alright, but the procedure is still the same. Okay, I'm not going to repeat myself. I'm just going to show the solutions. 14, same process. Here's the solution. But be very careful. This was 3.5. So when you subtract it from 3, it became 0.5. 0.5 squared is 0.25. So the answer is square root 36.25. Here, for 15, you are just given the letters P, Q, and J and K. When you make the substitution, it gets to this point where it's just J minus P squared plus K minus Q squared. Leave it like this. There's nothing else you can do here. You can, but it's just going to make it more complicated. You would just want to leave it like this. This is just the distance formula is just having variables in it. Okay, there you go. Alright, let's go to the go part. So the go part here, I'm going to delete this. Just asks us to find the distance here using finding AB and BD. Okay, I'm just going to pull up Paint here so we can work on Paint for it to work much better. Alright, give me a moment to set up the Paint. Alright, so, okay, let's take a look here. Alright, so the first one, we notice that the y-axis here is -4. Right, and so this distance here would be the value, because you see how it's a 4 here. Do you see how it's a 4 here? That means this line why would not so this line is a 4, so therefore this is a -4 because it's going down, right? -4, but the distance is still 4. Okay, this is also -4. Oops, that sort of blocks it. Okay, -4. Okay, next, this is to the 10. You see how this is in the x, so we would say this from, oh my god. Alright, sorry about that. My batteries on my headphone ran out. So, okay, so, oops, sorry. So this distance is defined by 10. You should see that right there. So that means this value is also going to be, this value here is going to be 10 as well. That means this value is also going to be 10. Alright, next one, let's make that blue. Notice that going from up here to here, it has the value of 6. So you would say that the coordinate up here is 6. Oops. That is probably the 6 right there. Oops, sorry. This is 6, that's 6. This was 10. So therefore this has to be 10. That means this also has to be 10. Right, because the distance here, watch, the distance here is also going to be 10. Right? Likewise, that's 10. Okay. That's 6. and oops, sorry, that is 6, and this is 4. Okay. They asked us find HB. HB, where is it? HB, it goes from 10 to 10, so the distance here would be 10 plus 10, which is going to be equal to 20. There's no units, right? There's no meters or yards. And BD, where's BD? B is right here, D is down there. Goes from 6 to negative 4, right? So 6 plus 4, 6 plus 4, which is going to be equal to 10, right? It has to cover 10 distance here, right? Because 6 here plus the 4 here gets you the distance of 10. Remember, the distance is always a positive value. Right, so there you go. That would be the answer to the first one. Let's just take that out, and let's do the second one. It's going to be the same procedure. Okay. Give me a moment to set up the paint. But the process is going to be the same. All right, let's take a look. Okay, 0, 0. This is going to go down to the value of, looks like it's negative 3, so the distance here is going to be 3. Therefore, what's going to have the value of 3? This is going to have a value of 3. Oh, it's really negative 3, just to let you know. The coordinate is really negative 3. So, alright, so the coordinate here is negative 3. The coordinate here, which is positive, that's going to be positive 3. That means this is also positive 3. Okay. Oh, no, hold on. Is that also positive 3? X, Y. Ooh, no, the Y here is 0. So that's wrong. So that's 3. That's negative 3. That's good. Okay. Because that's down. Okay. Let's go to green. Let's do that going up. How much is that? That looks like it says it goes up 4. So they say that goes up 4. Good. So the point here is 4. This point here is also going to be 4. That means this also has to be 4. Let's make this blue. Goes from here to here. This gives you the value of 4. You see, it says 4 here there. So that's 4. That means the same value of this will have to be any of this. So this has to be 4. Good. This goes up how much times? 4 times. That's a 0, so this is going to be a 0. Right? Because it didn't go anywhere up in the x-axis. It stayed at 0. Good. Here, how many times did it go to the left? It went negative 8. Right? It says negative 8 here, so I could make that purple. See, it's negative 8. So they say this is the distance of, well, the distance is 8. Okay? The distance is still 8, but the coordinate is negative 8. Good. Say that's negative 8. The value here of y would be 0. So I could grab that, plug that here. This was also the 0. Good. This was also a 0. That's grabbed from the y. There you go. How much did this bring this down? This was a 4. Right? but it's really negative. Wait, is it? Yeah, it's positive 4. This is a negative 3. Oh, because it is in the y-axis. Good, good. This was how much in the x? That was bringing down that 0. Okay, there you go. Those would be all the values. So what is dB? In dB, it goes from negative 8 to 4. So it would be the distance would be 8 plus 4, which is equal to 12. And the last one, CF, it goes from C to F. It goes down 4, then 3. So 4 plus 3 is equal to 7. So there you go. Those would be all your solutions for number 17. Okay, there you go. If you want to see 16 and 17 in all its steps. Okay, make sure you draw those lines so you can see the distance. Okay, but there you go. Those are all your homework solutions for the 8.1 Ready Set Goes.